You are watching AliAziz YouTube channel.
8 Disciplines of Problem Solving, 8D. For fresh and experienced candidates. AliAziz Quality Education channel providing you the job best interview related videos, so don't forget the subscription button. Introduction to 8 Disciplines of Problem Solving, 8D. The 8 Disciplines of Problem Solving, 8D, is a problem-solving methodology designed to find the root cause of a problem, devise a short-term fix and implement a long-term solution to prevent recurring problems. When it's clear that your product is defective or isn't satisfying your customers, an 8D is an excellent first step to improving quality and reliability. Ford Motor Company developed this problem-solving methodology, then known as Team-Oriented Problem Solving, TOPS, in the 1980s. The early usage of 8D proved so effective that it was adopted by Ford as the primary method of documenting problem-solving efforts, and the company continues to use 8D today. 8D has become very popular among manufacturers because it is effective and reasonably easy to teach. Below you'll find the benefits of an 8D, when it is appropriate to perform and how it is performed. What is 8 Disciplines of Problem Solving, 8D? The 8D problem-solving process is a detailed, team-oriented approach to solving critical problems in the production process. The goals of this method are to find the root cause of a problem, develop containment actions to protect customers, and take corrective action to prevent similar problems in the future. The strength of the 8D process lies in its structure, discipline, and methodology. 8D uses a composite methodology, utilizing best practices from various existing approaches. It is a problem-solving method that drives systemic change, improving an entire process in order to avoid not only the problem at hand but also other issues that may stem from a systemic failure. 8D has grown to be one of the most popular problem-solving methodologies used for manufacturing, assembly, and services around the globe. Read on to learn about the reasons why the 8 Disciplines of Problem Solving may be a good fit for your company. Why apply 8 Disciplines of Problem Solving, 8D? The 8D methodology is so popular in part because it offers your engineering team a consistent, easy to learn, and thorough approach to solving whatever problems might arise at various stages in your production process. When properly applied, you can expect the following benefits. Improved team-oriented problem-solving skills rather than reliance on the individual. Increased familiarity with the structure for problem-solving. Creation and expansion of a database of past failures and lessons learned to prevent problems in the future. Better understanding of how to use basic statistical tools required for problem-solving. Improved effectiveness and efficiency at problem-solving. A practical understanding of root cause analysis, RCA. Problem-solving effort may be adopted into the processes and methods of the organization. Improved skills for implementing corrective action. Better ability to identify necessary systemic changes and subsequent inputs for change. More candid and open communication in problem-solving discussion, increasing effectiveness. An improvement in management's understanding of problems and problem resolution. 8D was created to represent the best practices in problem solving. When performed correctly, this methodology not only improves the quality and reliability of your products but also prepares your engineering team for future problems. When to apply 8 Disciplines of Problem Solving, 8D. The 8D problem solving process is typically required when safety or regulatory issues has been discovered. Customer complaints are received. Warranty concerns have indicated greater than expected failure rates. Internal rejects, waste, scrap, poor performance or test failures are present at unacceptable levels. How to apply 8 Disciplines of Problem Solving, 8D. The 8D process alternates inductive and deductive problem-solving tools to relentlessly move forward toward a solution. The Quality 1 approach uses a core team of 3 individuals for inductive activities with data-driven tools and then a larger subject matter expert, SME, group for the deductive activities through brainstorming, data gathering and experimentation. D0, Prepare and plan for the 8D. Proper planning will always translate to a better start. Thus, before 8D analysis begins, it is always a good idea to ask an expert first for their impressions. After receiving feedback, the following criterion should be applied prior to forming a team. Collect information on the symptoms. Use a symptoms checklist to ask the correct questions. Identify the need for an emergency response action, ERA, which protects the customer from further exposure to the undesired symptoms. D1. Form a team. A cross-functional team, CFT, is made up of members from many disciplines. Quality 1 takes this principle one step further by having 2 levels of CFT. A core team uses data-driven approaches, inductive or convergent techniques. The core team structure should involve 3 people on the respective subjects: product, process, and data. SME team comprised of members who brainstorm, study, and observe, deductive or divergent techniques. Additional subject matter experts are brought in at various times to assist with brainstorming, data collection and analysis. Teams require proper preparation. Setting the ground rules is paramount. Implementation of disciplines like checklists, forms and techniques will ensure steady progress. 8D must always have 2 key members, a leader and a champion/sponsor. The leader is the person who knows the 8D process and can lead the team through it, although not always the most knowledgeable about the problem being studied. The champion or sponsor is the one person who can effect change by agreeing with the findings and can provide final approval on such changes. D2. Describe the problem. The 8D method's initial focus is to properly describe the problem utilizing the known data and placing it into specific categories for future comparisons. The is data supports the facts whereas the is not data does not. As the is not data is collected, many possible reasons for failure are able to be eliminated. This approach utilizes the following tools. 5 why or repeated why, inductive tool. Problem statement. Affinity diagram, deductive tool. Fishbone/Ishikawa diagram, deductive tool. Is/is not, inductive tool. Problem description. D3, interim containment action. In the interim, before the permanent corrective action has been determined, an action to protect the customer can be taken. The interim containment action, ICA, is temporary and is typically removed after the permanent correct action, PCA, is taken. Verification of effectiveness of the ICA is always recommended to prevent any additional customer dissatisfaction calls. D4, root cause analysis, RCA, and escape point. The root cause must be identified to take permanent action to eliminate it. The root cause definition requires that it can be turned on or off, at will. Activities in D4 include comparative analysis listing differences and changes between is and is not. Development of root cause theories based on remaining items. Verification of the root cause through data collection. Review process flow diagram for location of the root cause. Determine escape point, which is the closest point in the process where the root cause could have been found but was not. D5, permanent corrective action, PCA. The PCA is directed toward the root cause and removes/changes the conditions of the product or process that was responsible for the problem. Activities in D5 include establish the acceptance criteria, which include mandatory requirements and wants. Perform a risk assessment/failure mode and effects analysis, FMEA, on the PCA choices. Based on risk assessment, make a balanced choice for PCA. Select control point improvement for the escape point. Verification of effectiveness for both the PCA and the escape point are required. D6, implement and validate the permanent corrective action. To successfully implement a permanent change, proper planning is essential. A project plan should encompass communication, steps to complete, measurement of success and lessons learned. Activities in D6 include Develop project plan for implementation. Communicate the plan to all stakeholders. Validation of improvements using measurement. D7. Prevent recurrence. D7 affords the opportunity to preserve and share the knowledge, preventing problems on similar products, processes, locations or families. Updating documents and procedures/work instructions are expected at this step to improve future use. Activities in D7 include: review similar products and processes for problem prevention. Develop/update procedures and work instructions for systems prevention. Capture standard work/practice and reuse. Assure FMEA updates have been completed. Assure control plans have been updated. D8. Closure and team celebration. Teams require feedback to allow for satisfactory closure. Recognizing both team and individual efforts and allowing the team to see the previous and new state solidifies the value of the 8D process. Activities in D8 include: archive the 8D. Documents for future reference. Document lessons learned on how to make problem solving better. Before and after comparison of issue. Celebrate successful completion. 8D and root cause analysis, RCA. The 8D process has root cause analysis, RCA, embedded within it. All problem-solving techniques include RCA within their structure. The steps and techniques within 8D which correspond to root cause analysis are as follows. Problem symptom is quantified and converted to object and defect. Problem symptom is converted to problem statement using repeated whys. Possible and potential causes are collected using deductive tools, i.e. fishbone or affinity diagram. Problem statement is converted into problem description using is/is not. Problem description reduces the number of items on the deductive tool, from step 3. Comparative analysis between the is and is not items, note changes and time. Root cause theories are developed from remaining possible causes on deductive tool and coupled with changes from is/is not. Compare theories with current data and develop experiments for root cause verification. Test and confirm the root causes. Example, multiple why technique. The multiple/repeated why, similar to 5 why, is an inductive tool, which means facts are required to proceed to a more detailed level. The steps required to determine problem statement are: problem symptom is defined as an object and defect, i.e. passenger injury. Why? In every case SUVs roll over. Why? In every case, it was preceded by a blown tire. Why? Many explanations may be applied, therefore the team cannot continue with another repeated why past blown tire. Therefore, the problem statement is blown tire. Why? Low air pressure, tire defect, degradation of an interface, and high ambient temperature. Countermeasures assigned to low pressure and tire defect. This example uses only 4 of the 5 whys to determine the root causes without going further into the systemic reasons that supported the failure. The repeated why is one way to depict this failure chain. Fault tree analysis, FTA, could also be used.